Section 5-6 is about inequalities in one triangle. And to begin, I want to introduce you to a property of inequalities that we'll use a few times in this lesson. It's called the comparison property of inequality. And what it says is if A is equal to B plus C, and C is bigger than 0, then we know that A has to be bigger than B. So let me give you an example. 7 we know is equal to 2 plus 5, and 5 is bigger than 0. So 7 must be bigger than 2. Okay? Now, I know that seems really simple and maybe not even very useful, but it will be useful, and we'll see how that is useful to us in the next slide. But the reason why it works is because 5 is bigger than 0. Okay? In this case, C is bigger than 0. So if I eliminate 5, I've lessened this side of the equation. And because I lessened that side, 7 must be bigger than 2. Okay, here's another example. 3 is equal to -1 plus 4. And 4 is bigger than 0. So if I eliminate 4, I know that 3 must be bigger than -1. Okay, because I've lessened this side. Now let's see why that's useful to us in the corollary to the triangle exterior angle theorem. Now, before we talk about the corollary, let's remember what the triangle exterior angle theorem said. Looking at this picture, we know that the measure of angle 1 is equal to the measure of angle 2 plus the measure of angle 3. Okay, or in other words, the exterior angle is equal to the sum of the remote interior angles. Okay, now we know that the measure of angle 2 will always be bigger than 0 because it's an angle. And we also know the measure of angle 3 will also be bigger than 0 because it's also an angle. So by the property of inequalities we just talked about, I know that the measure of angle 1 is bigger than the measure of angle 2, and the measure of angle 1 is bigger than the measure of angle 3. Okay, so that's using that property we just talked about, and I can conclude this. Now let's see how that's used in a problem. Using this figure at the right, why is the measure of angle 2 bigger than the measure of angle 3? Okay, well, I know that I'm looking for exterior angles. So I'm looking at angle 1. The measure of angle 1 must be bigger than the measure of angle 3 by that corollary we just talked about. Okay, now looking at this triangle down here, I notice that it is an isosceles triangle. And I know that in an isosceles triangle, the base angles, meaning angles 1 and 2, must be congruent. So I know that the measure of angle 1 is equal to the measure of angle 2 by the isosceles triangle theorem. Okay, now, since the measure of angle 1 is equal to the measure of angle 2, I can substitute this into this equation, and I get that the measure of angle 2 is bigger than the measure of angle 3. Okay?